Solving absolute value inequalities. So last time we took a look at absolute value equations. Now let's see what happens to inequalities when we put absolute value in them. So let's try the absolute value of x minus 6 is less than 13. So what is absolute value? Absolute value is just distance from 0. So let's think. What are the requirements if the distance from 0 of x minus 6 is less than 13? Well, it's going to have to be the actual value of it. The number is going to be less than 13, and it also has to be greater than negative 13. So x minus 6 has to be less than 13, and it also has to be greater than negative 13 in order for its distance, which is what absolute value is, in order for its absolute value to be less than 13. Now we can just solve this like a regular compound inequality. Add 6 to everything. And just to make sure you remember how to graph these, let's graph it too. Alright, we got numbers pretty far apart here. Let's see. What's just above 19? 20 is a nice even number. Just below negative 7 we have negative 10, and we can count by 10 here. So we have 19 and negative 7, between 19 and negative 7. Okay. 6 times the absolute value of 3x minus 2 minus 6 is less than or equal to 9. So, before we get to the whole inequality thing, we have to just solve this like an equation and get rid of this minus 6 here. Move it to the other side, make it positive, so it's going to be 9 plus 6 is 15. Now we can divide both sides by 6. This will be 15 over 2, which is 15 over 6, which is 5 over 2. Now, we have the distance from 0 of 3x minus 2 is less than or equal to 5 over 2. So what does this mean? Well, it means that 3x minus 2 has to be less than or equal to 5 over 2, and it also has to be greater than or equal to negative 5 over 2. So that its distance from 0 will be less than or equal to 5 over 2. Now let's get rid of this minus 2. We'll add 2 to everything. So this will be negative 1/2 is less than or equal to 3x, which is 5 over 2 plus 2 is 9 over 2. And now we can divide everything by 3. We'll get negative 1/6 is less than or equal to x, which is less than or equal to 3 over 2. Okay, now let's see how we're going to graph this. We have two fractions here. Let's see, our highest fraction is 3 over 2. And so let's say we're counting by 1/2. So negative 1/6 will be above negative 1/2. And now we're counting by halves here. Okay. Less than or equal to 3 over 2. Remember to fill in the circle for or equal to. Negative 1/6 is going to be right about there. Okay. Good. Now let's try something a little bit different. Let's try 3 times the absolute value of x plus 4 minus 8 is greater than or equal to 10. So this greater than is going to change things up a bit, but first let's just solve this. Move the 8 there, divide both sides by 3. Okay, now greater than has a different meaning because now we're saying the distance from 0 is greater than 6. So now we have two different possibilities. In order to make the distance from 0 greater than or equal to 6, we could have x plus 4 greater than or equal to 6. Or what's another way to make the distance from 0 greater than 6? It could be less than negative 6. That way we would also have a distance from 0 that is greater than 6 because we're going farther into the negatives. Now we're going to solve this as an OR inequality. So x could be greater than or equal to 2, or x could be less than or equal to 10. So now when we graph this, let's see, we have 2 and negative 10. These are 12 apart, so let's see, it's right in the middle, negative 4. We'll count by 3's here. Okay. They're going in opposite directions. Less than or equal to negative 10, or greater than or equal to 2. Okay. Okay, now let's go back to a less than inequality for a moment. In fact, let's throw a fraction inside the absolute value signs. Okay, so a couple of interesting things are going to happen here. The first is we have to divide by negative 4 to get rid of this. And remember, when you do that, divide by a negative number in an inequality, this less than is going to flip to a greater than. So negative 2 divided by negative 4 is 1/2. So now we're back to a greater than inequality. So what that means is the distance from 0 for all this stuff inside here is greater than 1/2. So there's two ways that could happen. It could be greater than 1/2, or it could be less than negative 1/2, because its distance from 0 is greater than 1/2. Now let's solve these inequalities separately. We're going to multiply everything by 2 here. Move the 3 over. Okay, and here, same thing. Multiply by 2. And there we have it. X is greater than 1 or less than 1/2. So when we graph this, you know, let's pick points that are farther away just to make it interesting. Let's pick 3 here. And, well, 3's too high. Let's pick 2 and 0. Okay. Less than 1/2 or greater than 1. So the only thing it could not be is anywhere from 1/2 to 1. All right. I like this theme of starting with a less than and seeing whether it flips to a greater than. But here, something very interesting is going to happen. When we divide both sides by 2, it's going to stay a less than. This is going to be negative 7 over 4. We see that the absolute value of x minus 1 is less than or equal to negative 7 over 4. And right away you should see that that is impossible. How can the distance from 0 be less than or equal to a negative number? Well, it certainly can't be less than it and can't be equal to a negative number either. There is no solution to this inequality. I always like to throw that in there. Alright, this time we'll start with a greater than. So, we gotta move the 5 over. Divide by 2. Now we have the absolute value of x minus 8 is greater than or equal to negative 1. And before you say there's no solution because it's a negative number here, really think about this. We're saying it's the distance from 0 is greater than or equal to negative 1. Well, we know it can't be equal to negative 1, but what if it were greater than negative 1? Well, greater than negative 1 could be any positive number. So since it's any positive number, there are actually infinite solutions to this inequality. There are infinite solutions here. So you have to really think about it when you get something like that. Okay, now let's try something even more interesting. The absolute value of x plus 3 is greater than or equal to 0. Whoops. So, here we're saying the distance from 0 is greater than or equal to 0. Well, we know that greater than 0 means all positive numbers. So there are once again going to be infinite solutions. And by the way, it can also be equal to 0 because if something is 0 away from 0, that means it's 0. Oops. Infinite solutions here. Now let's make a very small change here. Absolute value of x plus 3 is greater than 0, but not equal to 0. So if it can't be equal to 0, then we actually do have to have one of two things. X plus 3 has to be greater than 0 or less than 0. It has to be greater than 0 or less than 0 because it can't be equal to 0. This is saying the distance from 0 of x plus 3 is greater than 0. So that means the distance can be anything except 0. So because of that, it has to be greater than 0 or less than 0. That's how we say anything but 0. So now we see that x will be greater than negative 3 or x will be less than negative 3. So from this, what are we saying here? Now we're saying all solutions except negative 3 is greater than negative 3 or less than negative 3, but not negative 3. So this graph is going to be interesting. If we draw this number line, put a negative 3 here, you just put any numbers over here, and the reason is because, look at this. All solutions except negative 3, that means can't be negative 3, so we put an open circle around that. But it could be any number less than negative 3 and any number greater than negative 3. So that is how you would graph that one. Okay, so all four of these here are very uncommon. To get no solution, infinite solution, especially something like this. But I just thought I'd throw them in there to make it interesting. But the important thing is that you understand how to solve absolute value when it is less than and when it is greater than over here. There's two different types of compound inequalities. Make sure you know which goes with what. And that is going to conclude our first unit on solving linear equations and inequalities. So if you're comfortable with all this stuff, then go ahead and move on to the next playlist, which will be graphing.